Good afternoon to all of you. Good afternoon, Ria, Anvi. All of you, please let me know whether audio video is clear to all of you. Good afternoon, Neha, Swagatam, Keshav, Ranjit. Audio video is clear to all of you. Okay. So in the last class, as you all have seen, we have revised the complete environmental engineering part. The complete Maha revision session we have done it on Gate Wallah MEC channel. There we have done this complete topic. Now, as I said, two part I'm going to take. The first one, in this session, I'm going to talk about some important, or I will say some those PYQ which you generally ask in the Telegram group. These are the most discussed, or I will say PYQ for you. So these PYQ you have to practice. I think some of you have already done this while going through the PYQ part and all. But again, you have to try this question with a completely clear mind. Is that clear? Is that clear to all of you? So one by one, I'm going to give you PYQ. Total will try to at least 20 because the name itself of the session is Super 20. So minimum 20 PYQ will try to do this. Okay. Only one request. If you really want a honest discussion, nobody will open book. Nobody will open book. So with your understanding, with your, I will say, knowledge, you have to try these questions. Let's start with the first question. Only with your understanding, use calculator. If possible, use virtual calculator. If possible, use virtual calculator. Randomly, I will go. So one question will be from alkalinity, another question will be from wastewater or maybe air pollution. So randomly, I will go. Not in sequence. Okay, so I think Vinu, Anvi, Neha, Ria, they all are started giving D. Now, what they are asking you here in this question, they have given you a complete relation where alkalinity you are getting in equivalent per liter. And for that, they have given an equation to you, which is SCO3 minus 2CO3 2 minus plus OH minus minus H plus. Now, first of all, this is not a general equation. So here, each and every term they have mentioned, alkalinity they want in equivalent per liter. All these values are given in mole per liter. So this equation itself is given to you. So you have to apply as it is what they have given you. Like SCO3, they have given you 2 into 10 to the power minus 3 plus 2 into carbonate concentration is given to you as 3.04 into 10 to the power minus 4. And what about OH minus? pH they have given, na? So OH minus I can find it out. pH is 9, so OH will be 5, POH will be 5, and concentration will be 10 to the power minus 5. Minus 10 to the power minus 9. So this is what we get, but this value is in equivalent per liter. Now they want alkalinity as a calcium carbonate. So right now the value is in gram equivalents per liter. If you want to convert it, what you will do? With this value, if you want to convert it, what you will do? If you want alkalinity as CaCaCO3, whatever you are getting from this part, into 50, which is the equivalent mass, you want in milligrams, so that's why multiply 1000. Milligram as CaCO3. Many of you are having doubt regarding this question, I know. But because what you do generally, you try to apply normal alkalinity equation that we have written in the Is it clear? How much this part you got? Anybody who can tell me the value? Anybody who can tell me the value? Then we'll go for the next part. 0.003. This is 0.003. Is that what you are getting? Tell me the value quickly as possible. See, I don't want to use my calculator, so you have to be very quick. 2.6179 into 10 to the power minus 3. So this 10 to the power minus 3 will get cancelled out. You will have 50 into 2.6179. Roughly 130.895 milligram per liter. So with that, your answer will be option D. Is that clear? Okay. Now, another question which I am going to give you will be from a disinfection topic. Randomly, as I said, I will go randomly. Answer this. Which of the following is or are not active disinfectant in water treatment? And I want reason also from you. Why? Reason why I'm asking, because I know many of you have solved this PYQ already. So you have already remembered the answer also. What is the reason behind this? What is the reason behind this? Anvi, yes sir, I have doubt in it. Yes, Anvi, I have selected only those questions. In these questions, you generally ask doubt, either in Telegram or maybe in paid batch class. That's the reason these questions I have picked. Reason. Only giving option will not be enough here. I want reason also. See, OH minus hydroxyl radical is responsible, one of the responsible part in a ozone part. So OH minus, it is a responsible one for the disinfectant. Ozone, again, it is also responsible for the disinfectant. Hypochlorite, this is again free available chlorine. It is responsible for the disinfectant. But what about chloride ion? No, it is not a disinfectant. Like in water, sometime NaCl is present. So that chloride ion is there, na? Is that mean the chloride ion is going to work as a disinfectant for you? I'm asking this question to all of you. Those who are thinking about D option, for them I'm asking. In water, sometime NaCl is present, na? So NaCl, Na plus and Cl minus. So Cl minus is present in as a ion, you can call it. So does it act like a disinfectant to you? Obviously not. So which of the following statement not active disinfectant if they are going for, will go for the right answer as D. Why D is the answer? Is that clear to all of you? The concept behind this? See, when you talk about chlorine, chlorine, it dissolves in the water, it forms HOCl and OCl minus. This OCl minus and HOCl, these are the free available chlorine. Sorry, once again. HOCl and HCl. Now this HOCl dissociate into H plus and OCl minus. This OCl minus and HOCl, these are the free available chlorine. So yes, chlorine is a disinfectant, but not chloride ion. Clear? Okay. Like this, randomly I will select the question. So another question for all of you. Another question for all of you. Now this question came in 2021 Civil Engineering 2 mark. This question actually came from that part which you generally don't study. On a BTech level, on a GATE level, you don't study this part. In masters, when you will discuss the maximum mixing depth in detail and the dispersion model in detail, then these things we actually study. So somebody who have not or who are not able to solve this question, this is completely okay. This is completely okay. Actually, this question came because in 2021 they have introduced GATE Environmental Science branch, near to that only, and by the, you can say, effect of this, they have given a question which we generally discuss in masters. Because I have done masters in environmental engineering, so I can tell you this part. But okay, based on whatever knowledge you have, at least you can try. Based on whatever knowledge you have, at least you can try. Value of wind profile exponent for very unstable atmosphere is smaller than wind profile exponent for the neutral atmosphere. This was a MSQ question. MSQ type question maybe. Because according to the question, I think multiple option can be correct. What is the question? Read the statement given below. Select some I think some options was there, but I have converted this question into form of MSQ. So you have to tell me which option is right, which option is wrong. Choose the right option. I think A. Okay. See, first of all, in this question, one part which anybody can simply understand, downwind concentration of air pollutant in a downwind side due to an elevated point source will be inversely proportional to the wind speed. See, a basic concentration model also, if you see, C is inversely proportional to velocity. So if your velocity is more, definitely your concentration will be less. So inversely proportional to wind velocity, I can completely say this without any doubt. So B option is completely right. If you are saying B option is right, D has to be wrong. Because this D is just opposite statement of B. concentration is inversely proportional to the velocity. If a velocity will be more, basic logic, sir, if wind will be having a very, very high velocity, in that case, the concentration of the pollutant is going to decrease. It is again a very basic logic which anybody can apply. Now, next thing comes, which is the value of wind profile exponent, which is the alpha. For the very unstable atmosphere is generally smaller than the wind profile exponent for the neutral atmosphere. For unstable atmosphere, you will find the alpha is lesser. This is something now I think many of you guys are not knowing it. So this is something a new thing for you. If A is right, obviously the C will be wrong. A and B was the right statement for you. Now regarding A, I have given some notes for all of you to simply note it down. Because something new, na? So it has to be in your short notes. Something new for you, some new point for you, so it has to be in your short notes. So wind profile exponent, which is alpha, is depend on atmospheric stability, very unstable atmosphere, strong turbulence, flatter wind profile, and in that case, smaller alpha you will find. Smaller alpha you will find. Neutral atmosphere, lesser turbulence, larger alpha you will find. So alpha for a very unstable situation will have lesser value compared to a neutral one. Sir, if you correct A as the right one, then C is just opposite of this, na? Read the statement. Value of wind profile exponent for the neutral atmosphere is smaller than wind profile. Just opposite of this. If you are saying A as a right, C will be wrong. If you are saying B as a right, D will be wrong. Just opposite statement they have given. Just opposite statement they have given. Is that question and discussion is clear to all of you? Is that question and discussion is clear to all of you? Maybe in future, but I don't think so they will give you. Maybe in future if they will give you something related to this, if you have this thing in your notes, in short notes, at least you can try that question. Some people will say, sir, I am not aware about alpha. I know because you guys have not studied. For environmental science student, that is compulsory. They have to study air pollution model also. For a civil engineering student, it is difficult to understand because in GATE syllabus, air pollution model is not mentioned. If you will go for masters, air pollution model is something common for you. In our paid batch class also, a small discussion we had regarding the dispersion model, if you remember. Small discussion we had regarding the dispersion model. Clear? Okay. Now this is the question which I think many people gets difficulty because the first statement is completely not known to many of you. But what about this question? Why you guys are getting difficulty in this question that I'm not getting? Because I have seen this question, many of you guys are discussing in Telegram group. So why you guys are having difficulty in this question? Now this is a very basic 9, 10th, 11th, 12th class question for environmental science. 9, 10th, 11th, 12th class question. It is regarding the greenhouse gases. It is regarding the greenhouse gases. What this greenhouse gas will do? Generally, the short wave radiation which is coming, short wavelength I am talking about, solar radiation which is coming, they actually pass that. So short wave radiation will be passing through this, and they absorb the long wave radiation, whatever it is coming, or maybe the long wave radiation which is a reflection, or you can say as a radiation from the Earth's surface, that also they absorb. And by this only they are maintaining a global temperature, and that is something which is required for also for all of us to live in this planet. So in that case, here if you select the right option, the D option is perfectly right. Greenhouse gas allows the incoming short wave length solar radiation to pass through the Earth's surface and absorb the long wavelength radiation coming from the Earth surface. So with this, D option is perfectly right. I have made a diagram also for you, just in case if you want to note it down something. Just in case if you want to note it down something. But as I can see, all of you, I think only 1 or 2 guys have given me the wrong answer. Most of you have given me D answer as the right answer. Okay. Now one more question which came out of syllabus, you can say, or maybe it's a part of Masters in Environmental Engineering. And these 2 questions came because of environmental science as a GATE paper they have introduced. But after 1 or 2 years, they have understood that now that they are actually going beyond the civil engineering GATE part. Now they are not asking this part. Now from last 2-3 years, again I am noticing it. Now only for 1 year and 2 years they have asked. I think around 2020 GATE and 2021 GATE. Why I am quoting this question to you? Because many of you, what they do, they see this question in GATE PYQ and they get, oh, sir, we have to learn all the dispersion model also, Gaussian dispersion model also, all type of box model also. No. If you are going for GATE civil, not required. If you are going for GATE environmental science, it is required. Which of the following statements are true in relation to the maximum depth Dmax in the atmosphere? Dmax in the atmosphere. So I think all of you have given B and D. Okay, B and D means the ventilation coefficient depend upon the D maximum and the vertical dispersion of pollutants occur up to D maximum. Okay, let us talk about this. First of all, the concept. Basic concept, if you go, it is the ventilation coefficient. It depends on maximum mixing depth, which is MMD, or you can call it as D maximum, and the wind speed. So as you all guys are saying, sir, ventilation coefficient is depend on D maximum. So yes, it depends on D maximum, which is right also. I think all of you have given me B option also. Now the next thing is, a smaller D maximum will have a smaller air pollution potential. Now here you have to understand, if ventilation is more, basic logic again, if ventilation is more, the air pollution potential for that area will be more or less. All of you can answer this. See, again, I'm not here, I'm not something which want to discuss only the answer. You have to understand the explanation also. So you all have to take part in the discussion. If ventilation in a particular area or in a common ventilation coefficient in a particular area is more, what about the air pollution potential? It will be low, na? They are opposite. They are opposite. If ventilation coefficient is high, the air pollution potential for that area will be low. Again, a basic logic. With that logic, you all can remove the third part actually. A smaller D maximum will have a smaller air pollution potential. No, that is actually wrong. Okay, so C option is against this discussion which we had just now. Now the two part, D maximum is always equal to the height of layer of unstable. D maximum is basically what? Maximum mixing depth. How you find out maximum mixing depth? Just in a diagram, if you want to find out, there will be a ALR, there will be a ELR, wherever they are meeting or wherever they are intersecting that point or that point height from the ground, you are calling it as a maximum mixing height. Now, is it sure? Is it surely I have given you something that D maximum is always equal to the height of the layer of unstable? No. Not always. Not always. So in that case, A statement is wrong for us. Not always you will find that D maximum is always equal to the height of the layer of the unstable layer. No, again, not completely true. May or may not. Next, vertical dispersion of pollutants occur up to D maximum. Vertical dispersion in a vertical direction, whatever the dispersion will take place, that will occur. That's why the name itself comes now, maximum mixing depth. Maximum mixing depth. D maximum is actually what? It is maximum mixing depth, MMD. So yes, D can be the right one. B and D will be the right statement for all of you. B and D will be the right statement for all of you. Now this question you guys can answer. For this, the concept part I have given to you. If you want to take a screenshot, you can take, or if you want to write down, you can write down. Once it is noted, please let me know. Once it is noted, please let me know. The screenshot will be better because if you start writing, it will take time. Noted? Okay. Now, one more question. This will be the last. After that, then we'll solve few numericals. I know generally you guys are having difficulty in this type of theoretical question. Nah? So that is the reason I have given you these first. Again, it is a MSQ question, I think. I'm not sure about it. Yes, maybe. So check all the options. In these questions, you generally get doubt, na? Yes or no, I'm right or wrong? That is the reason I have picked. I just want to see your reaction. While solving gate PYQ, in these questions, you generally get the doubt. Okay, so I think most of you are going for A, B, C, multiple options. Long-term exposure to increased level of photochemical smog becomes a cause of chest constriction and irritation of the mucous membrane. Yes, that can happen. Volatile organic compound act as one of the precursor to the formation of photochemical smog in the presence of sunlight. You all have seen this. You all have seen this, that VOC is one of the thing in the reaction also which I gave you in my class. In reaction also you have seen that because of VOCs, ozone will be there in as it is form in the lower atmosphere. Ultimately, it is going to create the photochemical smog. So yes, it is one of the precursor. Increased level of carbon monoxide in indoor environment results in formation of carboxyhemoglobin, and the long-term exposure become a cause of cardiovascular disease. Yes, carboxyhemoglobin is basically COHB. Carbon monoxide definitely reacts with the hemoglobin part because they are having more affinity towards that, and in that case, C option is also right for you. Increased level of volatile organic compound in the indoor atmosphere will result in the formation of photochemical smog, which is a cause of cardiovascular disease. I want to know from your side why D is wrong, because nobody have picked this D option. So why you are confidently saying it, sir, D option is wrong? Why? Anyone? Why D is wrong? A simple answer I want from you. Why D is wrong? Perfect. First answer, that too from Abhishek, and that is perfect. Sirs, in photochemical reaction, the reaction we know, the first reaction where NO2 dissociate into NO and nascent oxygen, that does not happen if sunlight is not there. So for that reaction to take place, NO2 breaks into NO and nascent oxygen, we need sunlight. We need sunlight. So sunlight is the main thing. They are talking about indoor environment. In indoor environment, sunlight will not be there. Okay. Try this question. Try this question. We'll again come to the theoretical question, but I think 4 or 5 theoretical question we have solved. So now we can try some numerical question. You all guys are aware na, that again in evening 6:30 again we have a Mahabhyas session, and there the question will be mostly a known question to you. Like these question maybe while solving GATE PYQN you have done this question maybe 2-3 months back. But I will try in a Mahabhyas session, which is at 6:30 p.m. today, that all the question will be new for you, completely new for you. For the last question, Swagatam is giving reasons that only VOC is not sufficient. That statement also right, because photochemical smog will form not only because of VOCs. We need NOx also. A activated sludge process is designed for the secondary treatment of, they have given you the discharge. So while writing the given data, try to use all the symbols. After primary clarifier, the ultimate BOD of influent which enters into the ASP reactor, that means they have given you the YI. Treated effluent after secondary clarifier is required to have a ultimate BOD of, so YE. mixed liquor suspended solid, mixed liquor volatile suspended solid, that concentration they have given to you as MLVSS. They have given you 3000 milligram per liter. Now the hydraulic retention time and the means, one more thing, for underflow rate they have given you XU also 12,000 milligram per liter. The hydraulic retention time, that means detention time they have given you, and the mean cell residence time. So detention time is 0.2 day and the mean cell residence time, that is theta c, is 10 days. Okay. Respectively, a representative flow diagram of ASP is something which is shown here. The underflow volume of sludge wastages. So basically they are talking about this part, sludge wastage rate, that is the QW part. This is the QR, this is the QU, this is the QE, this is the Q0 or QI, whatever you want to write. So they are talking about QW. So as I can see in this question, they have not given you the XE part. So if they have not given you the XE part, what we will do here? They want in meter cube, na? Okay. The answer key which is given to you as in a gate, that is 37.5. Okay, we'll do that problem. Let us see whether we are getting this or not. Theta c is equal to Vx divided by QW into XU plus QE into XE. Now in this question, XE is negligible. So the formula will become theta c is equal to V into X divided by QW into XU. Now what about V? Discharge we have, time we have. So finding V will not be tough for us. V will be equal to Q into time. Q is 7500 meter cube per day into time is, detention time is 0.2. So volume wise it is 7500 into 0.2 divided by QW. Anyway, we want to find it out. Theta C, which is given to you as 10 days. XU, in the question they have given you 12,000. And X is, generally we use MLSS, but in this question they have given you MLVSS. So we'll take that only, 3,000. Now, can you guys give me the value of QW? Tell me whether we are getting this answer key or not. Are we getting the same? Okay. This question was easy. Why you guys are not able to do? Unit will be meter cube per day. This question was easy. Why many people have not, like 0.125? Why? What mistake you guys have done? What mistake you guys have done? May I know that part? Acha, you have put wrong data in calculator. Okay. Grid chamber, okay. After 1000 years, I have seen a problem from grid chamber in 2021 gate. Of a rectangular cross section is to be designed to remove particles with a diameter 0.25 mm and a specific gravity 2.70. So all the data you have to write down. The terminal settling velocity of the particle is, which is Vs, 2.5 centimeter per second. The chamber is having a width of 0.50 meter and has to carry a peak wastewater flow of, so discharge they have given. Giving the depth of the flow as 0.75 meter, if flow through velocity 0.3 meter per second has to be maintained. So Vf they have given you 0.3 meter per second has to be maintained using a proportional weir as a velocity control devices. At the outlet end of the chamber, the minimum length of the chamber which is required to remove 0.25 mm particles completely is. That means this particle they are talking about. For that particle, the terminal settling velocity is also given to you. Okay, bhaiya. Note it down. The minimum length of chamber to remove 0.25 particles completely. All the given data, first of all, if you write, D is 0.25 mm, specific gravity is 2.7, terminal settling velocity of the particle which is Vs, which is 2.5 centimeter per second, so 10 to the power minus 2 meter per second. The chamber is having a width of 0.5, so B is 0.5. Discharge is also they have given. Depth height is 0.75 meter. Flow through velocity which is Vf, which is 0.3. The minimum length of the chamber which is required. First of all, what is the formula for length? It will be flow velocity into time. Am I right? Flow velocity into time. The general formula for length, if I want to write, it is nothing but what? Flow velocity into time. So Rishu, Chandan, Amar, Ghoshal, Ankit, they all are saying 9 meter. All of you, if you remember in the class itself, I was telling to you, till now only few people have given me the answer. Only 4 or 5. Out of 45 students, only 4 or 5. If you all remember, in the paid batch class also I told you, from the grid chamber, do you really think any important question came? Even to solve this question, those who have solved, they know this. This formula which you guys are using it is actually a plane sedimentation formula, settling velocity, discrete settling velocity formula you are using it. Okay. Length, we need to find out. Flow velocity is 0.3, which is given to you. Time. As time I don't have, I will follow the 100% rule, where detention time will be equal to the settling time. As detention time I need, that is not there. So I will go for the settling time. Settling time is H upon Vs, that I know. H is something which is given to you somewhere 0.75. divided by Vs. Vs is also somewhere given, na? 2.5 into 10 to the power minus 2. After calculation, I think now you all guys are giving me 9 meter. Because this will be 9 meter. Now tell me, even though it's a grid chamber problem, but like all the concept which we have used, it is actually plane segmentation concept. Am I right or wrong? Too much data they have actually given just to confuse you, Ankit. They also know that this type of problem they can solve in 1 minute, but all these data was given just to confuse you. Please help me with the timetable. What timetable, Ucha? What timetable? Okay, so first answer which I got, that is from Amar. According to the answer key, the answer which is given to you as meter square. So with that, I think Amar has given the right answer. What about other? If you all remember, in the last class also I told you, while explaining the secondaries, while revising the secondary treatment unit, secondary settling treatment unit, timetable is basically very simple. Like if yesterday is if today is maybe, for example, tomorrow I will take fluid mechanics Maha revision session for you. So day after tomorrow, I'm going to take at 2:30 p.m. for FM, like this only, Super 20 class, where I will discuss the 20 most important question for the PYQ. Next, on the same day, at 6:30 p.m. on Wallah MEC channel, in a Hindi channel you can call it as, there will discuss the all type of not PYQ, some other question but related to your subject. That is something which is the plan for you ultimately. So after attending the Maha revision session, if you attend these two numerical, then it will be a complete revision for you. Okay, so I think this much time is enough to solve this type of question. As I already said you, sometime even if you forget the formula, you have to simply go with the unit, especially in environment subject. I need to find out the surface area. They are saying a unit meter square. What are the data they have given you? They have given you discharge value, which is 9600 meter cube per day. Let's see. Even some of you who are not remembering the formula, still you all can get this. Still you all can solve this. The concentration of solid in the flow from the addition tank is something which is given to you. You can consider that as X, which is 3000 milligram per liter. Solid concentration which is given to you. The clarifier is required to thicken the solid to 12,000 milligram per liter. So they want to change the concentration into 12,000 milligram per liter. That is what it is given to you. Hence, it is designed for a solid flux of 3.2 kg per meter square per hour. The solid flux rate for which you want to design your system, that is given to you as 3.2 kg. So that is the rate which is given to you, 3.2 kg per meter square per hour. Clear? Anybody having any doubt in this part? Anybody is having any doubt in this part? Now, first of all, the solid flux data what they have given you, if they have mentioned something like you can say recirculation is also included, like this, if something they have mentioned, so in that case we'll take something different. But if they have not mentioned that, so simple formula, solid flux rate, the unit what they are using it, kg per meter square per hour. So by any means on the top I have to maintain kg per hour. For that what I will do, I will take the discharge Q into the concentration X, but this value will be in meter cube or in a kg per day. So in that case you have to divide this value by 24. Because I want on the top, I want the kg per hour. For that reason, I have divided this value by 24. Okay, let us try to do this. Q is 9600, which is given to you. Again, X is 3000, which is again given to you, into 1 upon 24 divided by the solid flux rate is 3.2 kg. Give me the value. Once again, they have given you meter cube per day. Na? This you have to convert in MLD. Because we want in kg per day. So for this value, this Q value need to be in MLD. So this means 9600 meter cube. So that means 10 to power 3 liter. Then divide by 10 to power 6. It will be 9.6 MLD. Already I told you many times, whenever you want to convert some value in kg per day, especially the concentration part, you need to multiply with the discharge in MLD. That is the reason why I have taken that Q value in MLD here. If Q is in MLD, concentration in milligram per liter, ultimately it will be converted into kg per day. And I want kg per hour. For that reason, I have divided by 124. This is something which I have multiplied. Final answer from you guys is? Final answer from you guys. Chandan sir, I have missed 3 hours of last lecture. Then what to do now, sir? Whenever you get time, at least between this lecture to the next lecture, again you will have 2 hours, almost 2.5 hour time. Try to use that time to cover the Maha revision session. If somebody who have not covered, yet. Okay, we'll go for the another question. try this question. Missing converting, sir. Conversion part you are lacking. Conversion part you can, like, you can get confidence in conversion only after practice. Even though if you know all the units, but conversion part, unit conversion, you will get only like complete confidence only when you have solved 30-40 questions based on that. An analysis for the determination of solid in a return sludge of activated sludge process was done as follows. So many of you have given me option A, Ghosal, Amar, Vinu, and Rajesh. B option. An analysis for the determination of solid in the return sludge of activated sludge process. A crucible was dried to a constant mass of. So this is the crucible weight. C, I am taking it. 75 ml of well mixed sample was taken into the crucible. So this is the volume of the sample. V. The crucible with the sample was dried to a constant mass of 65.02 on a drying overnight. So when you dry this, you got 65.02. Now that is the total solid part, including, or simply I'm writing it here, total solid. As a given data, I am writing this. The crucible with the dried sample was now placed in a muffle furnace of 600 degrees Celsius at 600 degrees Celsius for an hour. After cooling, the mass of crucible with residue was left with now 63.145. That includes the non-volatile solid part, because volatile solid is gone. The concentration of organic fraction of solid present in the return sludge sample is. When they are talking about organic fraction, that means they are focusing about what? Volatile solid. So once they are talking about volatile solid, so volatile solid will be the volume is something which is 75 ml. I will convert this into liter, 75 into 10 to power minus 3 liter. And the given mass of volatile solid, how I can calculate? 65.02 gram. This is total mass, crucible mass plus the total solid part, 65.02 minus non-volatile solid and the crucible, which is 63.145. Difference of these two will give you the volatile solid part. Now this is in gram, you want this value in milligram. So multiply this with 10 to power 3. I want this value from all of you, and I also want to know why many of you have given me wrong answer also. So which is the right one? A or B according to you now? 65.02. This question, if you are doing it wrong, that means this gravimetry part I have explained you in, I will say, I think 10-15 minutes I have discussed this part, the gravimetry part. How this formula came in a complete story format I have discussed with you. Non-volatile solid, volatile solid, fixed solid, non-fixed solid. All these discussion we already had multiple times. Still, if many of you are giving me option A, I think in yesterday class also, in revision class also I have discussed this. Yes or no? I have discussed this or not? In yesterday's class also, while revising the quality of water part, the gravimetry I have discussed. Still many of you are giving me the wrong answer. So now you are giving option B as the right answer. Okay. This question, I think, this question also many of you guys are asking. By the way, this question is not a difficult question, but still many of you guys are discussing it in the Telegram. Yes or no? In this question also, many of you guys are having a doubt now. In this question also, many of you guys are having a doubt now. छूकर मेरे मन को किया तूने क्या इशारा बदला ये मौसम, छू कर मेरे मन को किया तूने क्या इशारा. Option is in next slide. Option is in next slide. I think many of you have actually solved this question, but you get doubt while selecting correct option. All are same. They have copy pasted. Diameter of anthracite particle is slightly greater than 0.35. Diameter of Amma, array, no. They have killed the mood of this question completely by doing the typing mistake. Shit. Completely they have ruined the question. Typing bhaiya na, they have completely ruined the question. The complete emotion of this question is ruined. And I also have not seen this. Then what's the magic? If all options are same only, then what's the magic in this question? In this question, the options was something which is, I will say, ki important to for all of you. Do you all have this question? This question was 2024 Civil Engineering 2-mark question. Last to last year they have asked. Do you all have this question? Accordingly try to answer this, because option will be the same, na? Accordingly try to answer this. First option was diameter of anthracite particle is slightly greater than 0.35 mm and diameter of ilmenite particle is slightly less than 0.141 mm. This was actually B option. This was actually B option. So what we can do, you have to select this question, because if you are not getting the options, na, in that case it is irrelevant. So if I will speak all the options, will you all write quickly? Because I want to see whether you guys are selecting the right option or not. So I want to see that, as here that person has done the typing mistake. So I have this question with me. So I'm telling you all the options. Slowly I'm going to speak, and I want you guys to quickly write this. The first option is diameter of anthracite particle is slightly less than 0.35 mm, and the diameter of ilmenite particle is slightly greater than 0.14 mm. That is the first option. Once again, I am repeating the first option. Diameter of anthracite particle is slightly lesser than 0.35 mm and the diameter of ilmenite particle is slightly greater than 0.14 mm. Option B, if I go, diameter of anthracite particle, option B is the same option which they have given you here. So option B is the same. Option B is the same. Here instead of greater, this is less. For option A, it is less. And here it is greater. So A and B option is something which I have written for you in this with a small correction. Next, third option was diameter of anthracite particle is slightly greater than 0.64 mm. 64 mm and the diameter of ilmenite particle is slightly less than 0.10 mm. Opposite of this, diameter of anthracite particle is slightly less than 0.35 mm and the diameter of ilmenite particles is slightly less than 0. Now, I have changed the complete option for you. Now you have to pick the right option. Now you guys have to pick the right option. What was the logic behind this question, first of all? Those who have started solving or those who have already solved? See, if they are using a multimedia filter, you always remember that flow is from coarser particle to the finer particle. So on the top, you will find anthracite coal will be there. Then the next one, which particle we are having? Anthracite is having a specific gravity of 1.5. Silica sand is having a specific gravity of 2.6 and then the ilmenite. Second one is the silica sand and the last one ilmenite. Spelling of ilmenite is wrong. Okay. Coarser particle, finer particle. Now in the question they told you that after backwashing the particles will settle forming the 3 layer again. This is something which is given to you. Diameter of silica sand particle is again given to you. That means for this particle the diameter is given to you as 0.20. Concept is very simple. If you will do the backwashing, definitely all these particles will be in suspension. All these particles will be in suspension. Now what you will do? Again, enemy is asking, enemy is telling us sound is not clear. Is it not clear? The same way I am speaking with the same setting. So if you want all these particles to again settle down after backwashing in a similar manner, what you have to maintain, that is something what they are asking you. Okay. So first of all, let us try to find out a basic thing, like all these particles settling velocity VSA-A, VSA-S silica, and VSI ilmenite. Let us find out this thing. I think these will not be the same. First of all, these will not be the same. The settling velocity you will find for ilmenite is definitely higher. After that, you will have the silica one, and the lower settling velocity you will find for anthracite. That is the actual logic. That is the actual logic. That is the actual logic. Why it is required? Because you want all these particles to settle in the same format, and that is possible only when the settling velocity of this particle is more compared to the silica, compared to the anthracite. Clear? But first of all, greater than part I am not taking it. First of all, equal part I am taking it, because I have the calculation data for Vs. GD squared upon 18 nu. I will use the Stokes law here. G is 9.81. So in both the cases, the same formula, same. Vs is equal to GD square upon 18 nu G minus 1. For all the particles, the dynamic viscosity is same, the G is same. The only thing which is changing to you is D and the G minus 1. So I'm writing only that part. So dA whole square minus specific gravity of anthracite is 1.5, which is given in the question, minus 1. ds they have already given you 0.2 mm. So 0.2, it is in mm, remember this, into specific gravity of silica sand, that is also given to you 2.6, and for ilmenite sand 4.2. So 2.6 minus 1 again equal to dA di whole square into 4.2 minus 1. So 2 times you have to do the equation. One is this one, another is this one. By doing or by equating these two, you can tell me the value of dA. By equating these two, you can tell me the value of di. These two value I want from you guys. This will be also in mm, and this will be also in mm. Tell me the value. I think this is solved by you during 2025 series. Yes, definitely. This is a GATE 24 question, na? Tell me the value of dA, tell me the value of dA is 0.357 and di is 0.141. We got the dA value 0.357 mm and di value 0.141. I think this everyone got. See, this is not the final value. This is not the final value. Why this is not the final value? Because equal settling velocity I don't want. Nah? I don't want equal settling velocity. I want the upper condition. The ilmenite is having the maximum settling velocity, then the silica sand, then the anthracite coal. This something I want. This something I want in the question. Now, if in a silica sand I will provide D actual diameter of the silica, this ilmenite, more than 0.141, then definitely this VSI value will be more. Do you all agree? If I will provide here for the anthracite the diameter less than the 0.357, definitely the VSA will be lesser. So ultimately what I am going to provide here for dA, I want to provide lesser than 0.357 mm, and for this di, I want to provide greater than 0.14 mm, because this condition I want to maintain, not this condition. This is something I have done it just to get this value. This equate part I have done it just to get the value. So actual this condition I want to maintain it. If you want after the backwashing, these layers is same layer you are if you want to get in that case. Now I want you guys to select the option. Where is the option now? Now all of you select the option. Is that clear now? Is that clear now to all of you? Is that clear now to all of you? Okay. Now another question which many of you guys are asking, this one also. In this problem also, I think many of you guys are discussing in the Telegram group. Actually, this question is not difficult. I don't know why you guys are discussing a lot. Is that a really difficult question? Just by reading this question, tell me. Just by reading this question, tell me. Is it really a difficult question for you? I don't think so. K value is nothing is given. That means it is a mole per liter. I don't know. Actually, this problem is easy. Still, I find sir, today is Maha Abhyas series on Hindi channel. Please put new framed questions like most expected, Vedant Krishna. My student will answer you. They know what I am going to reply for this suggestion. Let's see what you other people are replying you. Hundred times I told that in a Mahabhyas session, this is a Super 20 session for PYQ. So here PYQ will be there. Most important PYQ will be there. That Mahabhyas session, the idea of Mahabhyas session is that to give you most expected question which is not PYQ. This I was telling from beginning itself. Same thing you are giving me a suggestion. So your suggestion is already considered. Okay. So as all of you guys are giving me answer very fast, very good. Chlorine gas 8 mg per liter as Cl2 was added to drinking water sample if the free chlorine residual and the pH was measured to be 2 mg per liter. First of all, they are giving you free chlorine residual. Free chlorine residual means what? That means HOCl is there and the OCl minus is there. Free chlorine residual. That is 2 mg. But this value is given as Cl2. As Cl2. I want to convert this value in mole per liter. What I will do? 2 mg per liter first of all divided by Cl2. I have to convert this in a mole per liter. So I have to divide by the this value by the molecular mass of chlorine. Chlorine molecular mass is 35.5 into 271. It is in gram. I need to convert this into milligram. Now after that, whatever you guys are giving me, that will be in mole per liter. Okay. What is the concentration of residual OCl minus ion they are asking. Assume that chlorine added to the water is completely converted into HOCl and OCl minus, and the OCl minus plus H plus is forming HOCl. That is what they have given you. Okay. By using this reaction, if I will write rate of reaction here, it will be product HOCl divided by the reactant OCl minus NH plus. So I can write K into H plus is equal to HOCl upon OCl minus. K is 10 to the power 7.5. H plus will be 10 to the power minus 7.5. If you multiply these two, here only I can write now. So 10 to the power 7.5 into 10 to the power minus 7.5 is equal to HOCl divided by OCl minus. That means HOCl is equal to OCl minus. So 2 OCl minus is equal to, this is nothing but how much? This part, 2.81 into 10 to the power minus 5, according to Anvi. Mole per liter. So in that case, the OCl minus will be 2.81 divided by, so according to the option, it is 1.408 into 10 to the power minus 5 mole per liter. Option A. Okay, so I think this question is something which is easy question for all of you, because many of you have answered very quickly. Achha, one more problem which I think came in GATE exam that year, many of you are not able to do, and reason it's completely okay, because this is something a part of your CPCB standard. Generally in your GATE preparation you don't read the manual and all. So if somebody who have missed this question, that is completely I can understand. Try this question. Try this question. In 11th, 12th, if someone chemistry is very good now, this problem that person can try. As I said already, this problem is slightly out of box, slightly more chemistry part in this. But somebody who is good in chemistry, that person can do this problem with a simple logic. With a simple logic. But if you are not able to do this problem, that's completely okay. You don't have to bother regarding this. Okay, no problem. I think this much time you have tried. I'm giving you a small. Basically, this formula is logical, but this concept I'm giving to all of you. Apply C corrected. C corrected is C measured into 21 minus oxygen divided by 21 minus the oxygen measured. So one is the reference one is the measured one. Like for this question, if I want to write C corrected, C measured is given to you as 42 milligram per 42 milligram per Newton per meter cube, whatever it is given to you, divided by 21 minus 21 is nothing but what? It is the oxygen percentage which is given to you. Minus first the standard and the reference 2. Measured, in a measured case it is 13% na oxygen. So in a measured case it is 21 minus 13. In a reference it is based on the reference 11% oxygen. How much you guys are getting after this? Again I said, if this question if you are not able to do, that's completely okay. No need to go again to read chemistry and all going for this. This is again a something which they have taken directly from the manual, and for this you don't have to bother. This type of question will not repeat. I'm not good in chemistry, sir. Some part of chemistry will be required. I know, I exactly am telling it. This type of question is something which is difficult for everyone, I know. But some part of chemistry is required for environment, that you also know. In a quality of water chapter, little bit chemistry is required. 52.5 milligram per Newton per meter cube. So the data what they have given you, the emission standard based on the reference which is 11% oxygen for HCl is 50 milligram per Newton. So you are getting more than this, na? You are getting more than this. So in that case, no compliances is required for you, as the corrected HCl emission is greater than the emission standard. C option will be the right option for you. C option will be the right option for you. So this part you can note down in your notebook. You can note down in your notebook. But further that you do, like after this, you don't have to bother a lot. Try this question now. Baghouse filter has to treat 12 meter cube per second of Baghouse filter has to treat discharge is given to you 12 meter cube per second. The baghouse is to be divided into 5 sections of equal cloth area such that one section can be shut down for cleaning and or repairing while other 4 sections continue to operate. So at a time 4 sections will be in operation, one section will be at a standby. An air to cloth ratio of 6.0 meter cube per minute per meter square cloth will be provided sufficient treatment to the gas. Okay. The individual bag are 32 centimeter in diameter and 5 meter in the length. Total number of bag required in the bag houses. So surface area provided by a single bag will be how much? First of all, it is pi into d. D is 0.32 into length, which is 5. So surface area of one bag, you can find it out. They have given you the air to cloth ratio. Air to cloth ratio. So by that you can find out the total surface area which is required for you. Again, Q divided by 6 meter cube per minute it is. So if you want to convert it, 6 divided by 60, I will do it. So 12 into 60 divided by 6, so it is 120 meter square. How much? This part you got? Total surface area according to Ranjit and Neha, it is Nehal. It is 5.02. So number of filter bag will be, which is required for you, which is 120 divided by 5.02, number of filter bag for operation. How much you guys are getting it? 120 divided by 5, roughly I can say 24. Roughly 24. Now what they are giving you some extra data that total they have to provide 5. Like if they have to use 4 now, one will be there as a backup, you can call. So the bag house is to be divided into 5 sections of equal cloth area such that one section can be shut down for cleaning. Now for that case, total how many you have to provide? Total how many filter bag you have to provide? One part extra. So number of filter bag provided it will be 24 into 5 by 4. I think roughly 30. Total 30 bag. Try one more question. Try one more question. I will try that from those part which we have discussed in this session, those like, for example, if this type of numerical I have discussed in this session, the same type of numerical I will not repeat in the Mahabhyas session, which is at 6:30. So I will not repeat the same type of numerical, so that if somebody who have watched both the session, it will be a complete numerical revision for the environment part. It will be a complete numerical revision for the environment part. Sample of air analyzed at 0 degrees Celsius and 1 atm pressure is reported to contain 0.02 ppm of NO2. Assume gram molecular mass of NO2 as 46 and its volume at 0 degrees Celsius and at 1 atm pressure as 22.4 liter per mole. The equivalent NO2 concentration is that, I think they are asking you. Okay. Basically 0.02 ppm means what? 0.02 meter cube of NO2 is present in 10 to power 6 meter cube of solvent. Here it is air for you. So if I want to convert this into microgram per cubic meter, microgram per cubic meter. So first of all, what I have to do? 0.02 meter cube of NO2 is present in 10 to power 6 na. So for 1 meter cube of air, for 1 meter cube of air, how much it will be present? It will be 0.02 into 10 to the power minus 6 meter cube. Minus 6 meter cube. Am I right? Now this I want to convert in mass to give this value in concentration, and for that I am going to use PV equal to nRT. According to the question, the P which is given to you as 1 atm, volume which is given to you as 22. Volume is 0.02, that is something which you want to convert it. Number of mole is given mass divided by, so given mass I don't know, that's something I want to find it out. Molecular mass is NO2, molecular mass will be 46, I think. 46. R is 0.0831 and temperature will be in Kelvin. Kelvin is around 0 degrees Celsius, no? So 273.15 Kelvin. The only thing which is unknown here is mass, and that I want in gram. Once again, this value here is, it is in liter, na? So this volume you have to convert it. Right now this is in meter cube. I have converted this into liter by multiplying 10 to power 3. Give me the M value. The value of M you will get in gram. The value of M what you will get in gram. Now for this question also, Mathli, Swagatam, Vinu and Ankit. Why this problem you guys are not able to do? We have solved, I think, maybe I think 2 and 3 problem based on the same concept in the classroom also. While teaching air pollution topic, we have solved multiple problem based on this concept. Still only 4 people are giving me the answer. Rest of you, those who have not given me the answer, what will be the value of M? And if you are having doubt, you can ask me. If you are having a doubt, you can ask me. In gram, what you guys are getting? In gram, what you guys are getting? This much time if you take, it is not good. Exactly how much you guys are getting it? 40.53 into 10 to power minus 6. If I want to write this part in microgram, it will be 40.53 into 40.53 microgram. This much is present in 1 meter cube of air, so the concentration will be 40.53 microgram per meter cube. Some of you who are having a doubt, sir, why this R value is written like this? That you can find it also. PV equal to nRT. P is given as 1 atm, volume is 22.4, number of mole, 1 mole, you want to find out R, and the temperature I am taking 273.15. So exactly what R you guys are getting it, that also you can find it out. So here the R value we are getting around 0.082 exactly. So in that case, whatever exact value we are getting it now, try to use that only to get a more accurate answer. 0.82. Now what you guys are getting it? So small thing, but it matters a lot, especially in exam type of situation. 4.107 into 10 to the power minus 5 gram. Again, if you want to convert this into microgram, it will be 41.07 microgram per meter cube. So 41.07 microgram per meter cube. This will be more accurate value based on the condition what they have given in. We are using that only. So I think many of you have given me the same answer, 41.07. That will be more accurate answer for this question. Okay. Answer this question. Last problem is now after explanation. I hope you all have understood completely now. Basically that value is given in concentration, given in ppm, and you want to convert into milligram per meter cube or microgram per meter cube, and for that we have used the ideal gas equation PV equal to nRT. Sometime in question they can tell you to convert from microgram per meter cube to ppm. So the same logic you have to use, the same formula you have to use. Now this question they have asked, why I am giving this question, because sometime what happens, especially in match the following type of thing, you don't know the all 4 data which is given here. All the 4 concept you guys are not knowing it. Maybe. Still you can get the answer. Still you can get the answer. All of you are giving me the option D. Let's check the answer key. That also shows D. If it is D, that means P you are saying third, Q you are saying 1, and R you are saying 4. Okay. Now in this question, The thing which you guys are not knowing, maybe some of you guys are knowing it, some of you guys are not knowing it. Trickling filter, one of the issue. Yesterday only we have discussed ponding. So Q it will be 1. B and C option will be cancelled. Then coagulation. Charge neutralization is one of the mechanism in coagulation. So R4, then R4. Only D option you are having. Now for reverse osmosis, some of you guys are not knowing it, that it is concentration polarization also. Now this some of you guys are not knowing it. I know. Completely understood. So sometime in a match the following type of question, something which is unknown to you, still you can find out the right answer. Still you can find out by only by R I did. Only by R, that means only by coagulation part. Okay. But R4 only one option is there. Only by R we can do, definitely. Samarth is telling. So this also you need to understand while solving PYQ. Another question is this part. Those you students who have done a complete class on activated sludge process, that person will be able to do this question. Those person who have only covered the ASP part in crash course or maybe in a revision course, they have not taken a proper class, that person will not be able to do this. The reason is why clarity about the plug flow and the complete mixed flow system. If you are having a clarity about a complete mixed flow system and the plug flow process, this question will be easy for you, super easy for you. If not, then this question will be super difficult for you. Very good. So many of you guys are answering this. That means it is clear to all of you. In this system, two type of system they are talking about. One is the plug flow system. Answer key is 1.12. So those who are giving 1.12, that is completely right. Two type of system you guys are following it. One is the plug flow system. In the plug flow system, what happens? If this is the tank, you will find the organic matter concentration is going like this. Exponentially it is decreasing it. And for that reason, you will find here the concentration they are using it C na. So I will use C only. C is equal to Ct is equal to C naught e to the power minus Kt. Minus because it is a decreasement, that's why minus sign comes. So Ct upon C naught is equal to e to the power k into t PFR. Ct upon C naught they have given 0.8 to you. So 0.8 is equal to e to the power k T PFR. Log, natural log 0.8 equal to minus k T PMFR. PFR. So PFR is equal to ln 0.8 divided by minus k. Divided by minus k. That is what I am getting. That is what I am getting for the TPFR part. Now similarly, if you do it for the complete mixed flow reactor, in a complete mixed flow reactor, the inlet concentration is C0 and the outlet concentration is, let's say, CT. This is a complete mixed flow reactor. And we have an equation for this, that CT upon C0 is equal to 1 upon 1 plus K into TCMFR. So CT upon C0, the same value they are taking it 0.8, 1 upon 1 plus K TCMFR. It will be 1 plus K into TCMFR equal to 1 upon 0.8, so it will be 1.25. Am I right? TCMFR is equal to what you are having? 0.25 divided by K. For both the reaction, as it is given in the question, for both the reactor, the rate constant is the same, completely the same. Even they are saying, while keeping the cross section of the reactor constant, assuming steady state. So if the cross section of the reactor is constant, even the velocity is also going to be the same. Okay. So can you all give me the ratio of TCMFR? They want a ratio of, they want a ratio of length, but I am finding the ratio of time for both the reactor. How much we got? According to Samarth, it is 1.12. Now in the question, if you see, they want you to find out the ratio of length. But as the velocity is itself the same, so length is equal to what? Velocity into time, na? And velocity is same only as based on the question, given data. So length scale ratio will be equal to time scale ratio, and that is nothing but 1.2, and that will be the answer. Now this type of question, sometime why I say only by taking crash course, yeah, only by watching Maha revision session will not be sufficient for you to get the full marks in environment, because of this type of question only. Because type of plug flow reactor, complete mixed flow reactor, extended reactor, all these things we have discussed in the paid batch class. Because of longer time, we are having facility to discuss all those things. So this question is something which is telling you to study the complete environment, then only you can get this type of question. After explanation, is that clear to all of you? Those who are not able to solve, after explanation, is that clear? After explanation, is that clear? Now one problem which again many of you guys are asking, but now I think it is clear for all of you. I can expect a quick answer from all of you for this type of problem related to the filtration part. I want to see, still this problem feels difficult for all of you. Still this problem feels difficult for all of you. Why, bacha? Why this problem feels difficult? Many times I have explained you. What is TB? time at which the turbidity of the effluent from the filter is now greater than 2.5 NTU. That is what we are calling it as TB, time to reach the breakthrough. Second thing is the TH, which is the time for reaching the terminal head loss equal to 3 meter or more than that. So that is the TH. Now, first of all, they are talking about by increasing the filter depth, keeping all other conditions same. So if you increase the filter depth, yesterday only I told you, when you increase the filter depth, that means you are giving more time with the filter media. Na? The water is in contact with the filter media for longer time because the filter depth is more. In that case, the efficiency will improve or it will decrease. In that case, the efficiency will increase or decrease. You only will comment. In that case, the efficiency will increase or decrease. You only will comment. The efficiency will increase, na? And efficiency will increase. So in that case, time to get this effluent part having more turbidity, that time will come early or late. You only will comment. You only will comment. I'm not going to comment the answer. If your system is working with a very good efficiency, time to get this condition when the system effluent is giving you turbidity higher, that will come late or early. So TB will increase or decrease? It will increase, na my dear. Then why you guys are going for option D? Why you are going like in the D option it is TB decreases, na? So why you guys are going for D? Come to the next part. If you increases the filter depth, you only are telling that sir efficiency will improve. So if efficiency will improve, that in that case the system will remove more particles, system will remove more solid particles, more dissolved particles, more impurities will be removed. So the chances of occurring a clogging condition or a choking condition in a filter bed will be or something which is going to occur early or late. The filter will choke or filter voids will get clogged, filter voids will get completely packed early or late. Because now your efficiency is good, na? If your efficiency is good, that means you are going to trap more particles. Your voids are getting choked as early as possible. So if voids are getting choked, or I will say the clogged, completely packed by the impurities, so in that case the outlet water movement, the outlet flow rate, the effluent flow rate from the filter will be low, or slowly it is getting low. In that case, once the outlet flow is, see, input is always the same, input is inlet level is always the same. If outlet level is falling, so the difference between these two is what? It is the terminal head loss, na? That terminal head loss will increase, and that increase occur early or late. That increase in the terminal head loss, this situation where you are getting terminal head loss more than 3 meter, that can come early or late. That can come early or late. Now you guys can select the option again. I'm again giving a chance to you. Amma, still somebody is giving B. Are B, just now I told you, na, B is going to increase, but what about TH? This is also increasing in option B. The right answer will be option A. After explanation also somebody is giving me B. I know many of you guys have simply remembered a table. That table also I'm going to show you. But I, as a faculty, what I want from you, you have to understand these things with the logic. How many table you will remember? How many table you will remember? Already you have so many things to remember. Answer the next question. The data is same only the last line changes. I know in like one of the student, that person sended me, sir, a complete simple table is there na sir. I will mug up this table. Why you are telling me this logic? Too much difficult for us to remember, sir. Now it's up to you. You want to remember, you want to understand the logic, or you want to remember the table. It's up to you. Yesterday also I gave you the table in the revision class. For me it is difficult to remember all the things. So I go with the concept, I go with the logic. Now again the same thing. Only apply the logic. I know all of you guys are going to give me the right answer. If you only apply the logic. What logic here? We are using it. The effect of increasing the filter loading rate while keeping all other conditions same on TB and TH is. If you increasing the filter loading rate, that means more amount of water you are going to treat early, or large amount of water will be treated early. In that case, there will be a chance that the effluent, it is like if you are using a filter and only 3 to 4% is living in that home, so less amount of water will be filtered on a daily basis. But now in that home, 40 people are living there now. Definitely they are going to use the water. Definitely they are going to treat the water with the same filter. That means now more amount of water will be filtered. You will find if normal servicing time for 3 to 4 people, if they are living, is let's say 3 months. But if 30 people are living, that servicing time will come within a month or within a month. Why? Why that happened? Because more amount of water gets filtered, and in that case the TB is going to come early, as well as even the TH is also going to come early, because the more amount solid, more amount of solid will be retained in the filter unit, and definitely the chances of clogging, the chances of choking of the filter media will come early, or that moment will come early. TB and TH both will decrease. Is that logic is clear to all of you? If logic is clear, I want to show all of you a simple big heart in the chat section. Only with the logic. Those who want to remember this concept as a logic, that person can show me the red heart in the chat section. Otherwise, there is a table. Try to mug up as much as you possible. जो भी आपकी whatever रटने वाली capacity है, if you are good in mugging up all these things, then I have given you a table also. For me, it is difficult to remember all these things, so I go with the logic. Okay. Solve this question. This will be the last question for today. Last question for this session. Then the next session will start from the 6:30. Next session will be started at the 6:30 p.m. Composition and energy content of a representative solid waste sample are given in the table. If the moisture content of the waste is 26%, the energy content of the solid waste on the dry weight basis is megajoule per kg. Okay. First you have to check this. 20 plus 45 plus 5 plus 10 plus 20. 50, 70, 100. Total 100. They want you to calculate the energy content on dry basis. Yesterday I gave you a formula. Energy content on dry basis will be equal to 100 minus 100 upon 100 minus moisture content into energy discarded here. The energy discarded part you can calculate 4.5 into pi, which is 20%, 16 into pi, which is 45%, 14 into pi, which is 5%, 32 into pi, which is 10%. Yesterday I gave you the formula for the energy discarded part. Just sum it. After summation you will get the energy discarded. So energy discarded, the basic formula which I told you, it is summation of pi into ei divided by 100. Same thing I am doing it here. What is the energy discarded value? Energy discarded value, Riya, Samarth, Swagatam, all of you. After summation, after adding all these things, what is the energy discarded value? जी हमें मंजूर है आपका ये फैसला जी हाँ. 13.6 as a energy discarded part. आपका ये फैसला कह रही है हर नर बंदा परवर शुक्रिया. According to Ankit, it is 18.378. That is the energy content on dry basis. Okay. So with this, not all type of problem we have done it, but definitely in this 2-hour time we cannot do all type of problem. But I will try that once you attend the next session also, which will be at the 6:30 p.m. So next session today at 6:30 p.m. on GATE Wallah 𝐂𝐚𝐿 channel. Those who are not in the group, this group is for the discussion purpose. related to the environment, related to the FM, related to the other subject which I teach, and this group is for all the updates. This is a GATE Wallah civil engineering group. This you all can join. Okay, so thank you so much all of you to watch this session completely. Again, we'll meet at 6:30 p.m. sharply, and again the same thing we'll do. Only thing is that those problems that we are going to discuss in the 6:30 p.m. class, that will not be the PYQ. That will not be the GATE PYQ, I will say more specifically. Okay. Chalo. Bye bye. Take care. We'll meet again in the 6:30 p.m. session. Till then, take care. Bye bye. Jai Hind.